So in this video we are going to capture motion from the live capturing video. So for doing this, first of all, you should know how to capture video. If you don't, so click on the I button of the video to learn. If you know, so you are ready to get started. So let's get started. So first we need to do is capture the first frame and store it. So we will create a variable first frame and it will be a none variable. Then we have to write a conditional statement here, which will be if first frame is none, then what will happen? Then first frame will be equals to k frame and then continue. So it will capture the first frame and then rerun the while loop and capture the second frame onwards. Now we have to blur our keyframe. The reason we blur our image is because it removes noise and provides accuracy in calculating difference. So we are going to use keyframe and cv2 dot Gaussian blur library, and the first parameter we have to pass is the frame, which is keyframe in our case, and the second is a tuple which decides the width and the height of a blur. So that will be 21 and 21, and the third one is the generally the standard deviation, so we generally pass 0 here. Now down here we will find the difference between the first frame and our current frame, so let's name it as delta frame and cv2 dot abs difference, absolute difference library we will use here. The first parameter will be the first frame and second will be the current frame. In our case it is the gray frame. Now like to show the image here, so cv2 dot im show and the name of the window will be delta frame and we'll pass delta frame here, so it is delta. Now let's save the script. And also I want to print the numpy array of the delta frame. Okay, let's save this script and run it. So if I come to the frame, you can see the difference is working. So if I press Q and now let's look at the numpy arrays of the delta frame. Now you can see that these bigger values are the difference frames which can be considered as motion. Let's say we will assign threshold, so if the difference between the first frame and the second frame is more than 30, we will classify that as the void pixel, and we will classify void pixel as motions in objects, and those values which have value less than 30 will be black pixels. We will do that using threshold method of cv2 library up here below the delta frame. So let's name it thresh frame. So cv2 dot threshold. So let's first give the delta frame that we want to threshold, and then the threshold limit which will be 30 in our case, then the color of the thresh pixels which will be white, which is denoted as 255, and there is one more value that we have to give, that is threshold method. There are lots of but we want thresh binary, and The threshold actually returns tuples. The first value is needed when you see other methods. We use other methods, but in this case we are using thresh binary, so it needs the second value of the tuple. So we will pass the index of 1. And now let's show the thresh window over here. So cv2 dot il show, name of the window will be thresh frame, and let's pass thresh here. And now what I want is I want to smooth the thresh frame. So for doing that I will use the dilute method of the cv2 library. So let's do it. Thresh frame equals to cv2 dot dilate, and now it requires the thresh frame. So we will pass the thresh frame and the kernel array. In this case we don't have any, so we'll pass none. And now we will define how many times we want to iterate to smoothen the thresh frame. I want to iterate 2 times. So let's now run the program. You can see is smooth, much smoother. So the trick worked. Now what we have to do is we have to find the counters using find counters method, which will store the counters in the tuple. So we will declare the variable of the counter. If you are using Python 2, using OpenCV 2, you have to do is cnts comma and assign it cv2 dot find counters. First parameter will be the thresh frame. So thresh frame, and it's actually good to copy the thresh frame so we don't override the actual frame. Then you have the method called cv2 dot render returns render external. The method will draw external counters of the objects that you will be finding. Yet another is the cv2 dot chain approx sample. This is an approximation method that OpenCV will apply for retrieving the counters. Okay, let's say we only want to keep the counters that have the pixels greater than 1000. For this we will first use the for loop. So for counter in nts if cv2 dot counter area of counter is smaller than 1000, then continue, and if the pixel is not bigger than 1000, repeat the for loop. Else when the frame is bigger than 1000, we want a rectangle surrounding that counter. So these are the values. Remember we are still in the for loop, so these will be the values of the rectangle, which is equal to cv2 dot bound rect contour. Now we have created the rectangle. Now it's time to draw it. For drawing the rectangle we have the cv2 dot rectangle method. First we will pass the colored frame. So the name of our color frame was frame, and then the upper left coordinate which will be x and y, and then the right lower corner of the rectangle, which will be right corner will be x plus w and y plus h, and then the color you want to give to the rectangle. So I want to give green, so value of white will 0, green will 255, and blue will 0. And then the last parameter will be the thickness of the rectangle, which I want to give is 3. So now let's show the window and see if it's working or not. For doing this, cv dot I am sure, let's name it motion, and then the color frame. Okay, save the script and run. Hope it runs without any errors. Yeah, it runs. If I now let's see if it is capturing motion. So yes, you can see it is capturing the motion of my hand. Perfect. Now you can see in the image back there, you will find the shadow of my fan. I will turn on my fan and let's see if it is capturing the motion of the shadow. You can see it is capturing the motion of the fan and as well as the shadow of the fan. So it is working fine. So that's all I wanted to show you in this video. So hope you enjoyed it, and let's see you in the next video then. Bye bye.